Hello, I'm Serhii, and pleasure to be here. It's a little bit fun that I'm not only the one who will have a speech about the war today, but I'm right after the panel when the happiness is the next big stage, and now I'm talking about the future of war. So let's start with this somehow. And we will talk what autonomy is, what AI is, and how it works at war, and why it's the best time right now to join this industry, to join us, and as the most consequent and the fastest growing thing in the world. Couple of words about me. I'm Serhii. I was running several teams in my past career, led AI in Ring.com. I just met many colleagues right now, happy to see you guys. But what matters more is that we started the deployment and commitment to production in 2023, and since that has around 100,000 combat operations, work with many defense units, and I wish, the only thing I dream is to contribute more to this story. And we recently raised the biggest investment round in the, at least known round in the Ukrainian defense history. So I'm here to share the lessons learned and the experience. And said that, let's talk about warfare in 2026 and about the next years. If I try to think on the lessons learned of the last 3 years, that's almost 3 years of war, almost 4, but more than 10. There are several key outcomes. The first one is the principle that scale beats tradition and scale beats innovation. This is what we see. Actually, it's not enough just to invent things, not enough to innovate. You have to deploy it and to scale it up. And that's a different problem. And one of the things that we didn't see in software industry before, that it's a production. It's a hardware manufacturing. So it's not enough just to increase the slider and deploy another 500 of instances of microservices or servers. It works almost always, but when you deliver them, you have to reproduce them. The second point is the tempo or velocity. It really decides durability, because it's every combat operation, every defense operation is a combination of observation, intelligence, decision-making, and actually action. And the faster you can do this, the better chances for survival you have, and that's a critical point right now. EW or electronic warfare is not a new reality, it's a new gravity. It works everywhere, it's just in 2026, it's a normal way of doing things. So nothing from civilian worlds work here. So GNSS doesn't work, normal radio comms doesn't work. The only thing that works somehow is the 4G or LTE connections, just because they were built for urban environments. And the last point is that interoperability really beats pure power and really beats instruments and innovations. Because, again, you have to be as fast as possible. For that, you have to work across several domains, across several systems, with intelligence, with decision-making, with deduplication, with filtering, and with actions. And especially in Ukraine, it means you have like hundreds of assets from dozens of different teams. They are hardly connected to each other, and that all falls to human hands. So on the one hand, Ukraine, I think for the end of this year, we will deploy around 5 million drones. On the other hand, they still are managed by human. There is at least one single human pilot behind every single drone. It means we still have to coordinate them via humans, which is pretty limited and is not so good in 2025 and 2026. One of the good examples for this, or study case, is both Rubicon, you probably know from Russia side, and Magyar or unmanned systems forces in Ukraine. So the key for success is to build the system out of the imperfect components, like with the drones you have, with the actual intelligence you have, build the business process around it with the conscripts, with the pretty immature humans, and start to scale it up. And this is how it works. But we have hardware, we have humans, and we have software. Guess what's the solution that can scale fast and can be updated or changed as frequently as you actually need it? Only software. So that's why we're here. And that leads us to point what autonomy is, because this is the buzzword, autonomy and swarming. I'm not happy anymore that I had a name for my company called Swarmer, because that's a buzzword for 2025, and nobody knows what is it. And that's one of the biggest misconceptions, I think, in defense for these years. Because autonomy is definitely not the point like when there is some evil AI who decides who lives or who dies, who makes all the decisions, and you can just manage it somehow. This is a different approach. It's some piece of the software that actually offloads the micro decisions at scale when humans just can't do this. For instance, when you have 25 drones, when you have 100 drones coordinated with all the stuff, right now you have actually a human, a pilot, an officer, intelligence officer who processes the information and makes every single little decision. But this is how it should be and how it could be. And the key direction here is it's removing risk. So we keep human in the loop everywhere, and this is the way how it should be built. But the actual micro decisions, the actual actions should be done by robotic systems, or by software, or by hardware, or the combinations. The problem is, autonomy is not something new, basically. So there are four, I think I've asked ChatGPT to show up the four most known names in industry, and there are several UAVs made by United States in cooperation with Europe and with Israel. So RQ4, MQ1, MQ9, I bet you've heard of some of them. So they were introduced 20 years ago. Like the RQ4 Global Hawk was introduced 25 years ago. And out of all these four systems that are widely adopted and used in different operations in Iraq, in South Africa, and all the conflicts, there is the one who was actually and technically capable to have the fully autonomous takeoff, landing, and flight. And surprise, this is the earliest, the RQ4, released again 25 years ago. So, but it's not autonomous. It's more about rather automation. But we were there, the technology was ready, it was not scalable enough. Because you have to have 5 people to run a single UAV. In modern army in Ukraine, for the small FPVs, you have to have 1 pilot. For the bigger ones, you still have 2 to 3. There is a pilot, there is navigator, there is like a payload operator. So we still scale drones by scaling humans. What if we will try to rebuild it by first principles, like the autonomy or the AI, so we will reduce this bottleneck? First of all, it's kind of a common knowledge that FPV changed the war, or the warfare, or the principle of war, but why exactly? There is the OODA loop, like observe, orient, decide, and act, and it's there in army for hundreds of years. This is the way how basically the decision is being made and how the action is being executed. So you first do some observation, then you make orientation, you decide what to do and act. With the tradition of warfare, it's a separate set of teams and humans. So you have fire control center or fire direction center, you have intelligence center, you have officer who makes the actual combat decision, and the team who fires the actual shot. When you have the FPV on the drone, it's been collapsed to like 5 seconds moment. So you have the camera, you have the explosives, you see it, and you just make the decision and strike it. That's the point. But when we start to think about having many of them, you can put some piece of the software to speed up small decisions and optimize small decisions, and it leads us to the different story. When every single drone can make small decisions and without involving humans. It speeds up everything. And starting from what I've said before, what we need in terms of the next generation of warfare, we have to be able to react fast, we have to build the interoperability, and we have to scale it up. So in contrary to humans, when you have like piece of the software, you can deploy it to as many drones as you want, to as many robots, as many systems, and update them pretty fast. So basically, the swarming debate itself is the way how the drones can work together without involving human limitations. This is why, by the way, the actual swarming is not flying informations. That's about making the efficient decisions and coordinate by themselves. So you as an officer are still in charge of making the engagement, setting the limitations or constraints, but then the system just follows your decisions, but you don't have to have 100 pilots for 100 points. And one of the biggest difference here, or misconceptions, is in contrary to humans, when the order and control system is being built vertically to overcome the human limitations. Because as a soldier, as an officer, as a spec ops, you can't keep in your head the whole battlefield picture. Computers, they are able to do this. So every single little asset can make the decisions, keeping in mind like information from hundreds of drones. In humans, you have to build the vertical integrated structure and like pass the information between chains. This is a big difference. And it leads us to conception of decentralized autonomy. When you have, in theory, all the units connected to each other, talking to each other, like following the same constraints, the same strategy, the same priority list, and they can do it like hundreds and thousands of times faster than humans behind them. This is what makes it so scary and so exciting at the same time. So, but that's the only way for us to move forward. The same story for counter UAV, not because we're talking about defense here. The same story about counter UAV. Right now, it's being built as a layered system, but it's hardly inside. It's still managed by humans, and we are very limited in terms of the information passing in the decision-making process, etc., etc. And we have hundreds of teams in Ukraine who work on different directions. And we're in a very unique position right now when probably this is the very first time in the history when the military doctrine is being redesigned by bottom-up principle, not by top-to-bottom. Just because we have the completely unseen scale of innovation, completely unseen scale of changes, and because we're in 2026 and we have a lot of technologies to help us here. And it means we're in a unique place when we're not having, we are not the origin and source of like innovation or rewriting the doctrines. We're the fastest innovation cycle place in the world. We just discussed the committing the code to production right now. Like, I'm not proud of it in 2026, but in 2023, I was updating the code and hotfix, literally being logged into the drone, which is hanging on top of the Russian target, and like the payload just didn't lift off. So I have to fix some kind of PWM numbers, like in real time. Serhii, you have 15 seconds, or they will hit the drone. This is the actual velocity we work with. But most of the components and software solutions and most of the hardware are still based on like solutions from 60 years ago. That's why we're very limited, and we have to update it somehow with the software parts. And now it comes to the question why it's so hard. Swarming is easy, why nobody did it before? Like last now targeting is easy, why nobody did it before? Let me ask to the audience. How many of you tried to build the visual navigation system or last mile targeting system or something to help drones or something to help like which looked pretty easy from the very beginning? So we have 1, 2, 3 people. And one of the point is it's really easy from the beginning when you just, okay, I can pull some algorithm, it works, but then we face the story that it just doesn't work at the real combat. It just doesn't work with the real drones or real robots. But why? First of all, most of the hardware, and even in 2026, is being built with a pilot in mind mental model. What I mean? If something goes wrong, there is a human pilot who can jump in, override the control, and unsnuff the situation or fix the situation. When you have 20 drones on top of your head, there is no pilot who can jump in and basically fix it. But it's not only about the actual application. It's about the way how we as an industry, as a software engineers, as hardware engineers, approaching the development. Because when there is no pilot with vertical control, you have to introduce a very different quality bar, a very different testing bar, a very different set of requirements. Because there is no way to cancel something if something goes really wrong. That's why when a drone manufacturer having some issues at the testing field loses one drone, we lose like 10 in the closest forest. There is like a huge cemetery of drones near Kyiv. The second big point is everything that we brought here from the civilian world, like starting from large language models, like with computer vision, with decision-making trees, with whatever else, it simply doesn't work in defense world. just because there is nobody tries to put a masking net on top of your target or top of your point. Nobody tries to hit you. Nobody tries to, basically, that's not hostile environment. And when you're building a delivery system, nobody tries to jam you, and at least as a rule of the thumb. Nobody tries to jam you or to disrupt your communications. And when we pull something from civilian world, oh, it worked for me, like image recognition, what could go wrong? But the bar is completely different. And we have to reinvent every single piece of this, basically. So that's the key point here, that despite, like, there are hundreds of teams right now, there are a lot of technologies that already, like, proven, combat proven, and deliver a lot of value to the battlefield. There are tons and tons of technologies and the building blocks that we have to reinvent. So I believe I'm the single speaker here today for the defense, so come join us. That's the most consequent and the fastest story, and basically the most valuable and the most meaningful in this decade. And to this point, years ago, warfare was limited by the hardware mostly. By the way, how can we scale hardware? Then, over the last 10 years, it went to a point when warfare is limited more by the networking, by the connectivity, by the interoperability. Right now, we're facing the moment in time when the warfare advanced is limited by the software and by AI. And there is nobody other except us who can build it in a way that we can trust our solutions, we can trace them, and we can use them. And it's not something from the able books, it's something that we can use on a daily basis. And democracy can't defend by itself, so we can't follow the Russian strategy and, like, defend ourselves sacrificing people. So there is the only way for us to do this is to let the drones do it. I think that is it. I will save you some time for a good coffee, and thank you so much.